All right, moving on, we're going to discuss equation 5 in this video for this foundational paper on generalized linear models. I'll include the link to this paper and the complete playlist in the description of this video. Equation 5 follows pretty directly from equation 4, so this will be a relatively short explanation here. So let's go ahead and move to the blackboard and talk about equation 5. So previously we showed that the second derivative of the function g equals this what we're calling capital V. Okay, and so now we have the second derivative of the log likelihood with respect to theta equals this alpha of phi times that V. All right, so let's start with the left-hand side of this equation and briefly go through that second derivative once more. So from equation 3, which again we showed this in a previous video, we have that the first derivative of the log likelihood equals alpha of phi times z minus mu, right? And mu equals that first derivative of the function g. Okay, so I'm actually going to just go ahead and erase mu. Instead of writing mu there, let me write that first derivative of the function g. All right, so now when I'm finding the second derivative, I'll remember that that is of the function, that is a function of theta. Okay, so let's go ahead and distribute this, and I get alpha of phi times z minus alpha of phi times the first derivative of g of theta. Okay, so then the second derivative of the log likelihood with respect to theta, I have this first piece does not involve theta, so it's 0. And then the second piece, I have that negative, that constant out front, and then times the second derivative of that function g. All right, so this is the second derivative of the log likelihood with respect to theta, which is the left-hand side of this equation. All right, and then I see that basically I have the same thing, except I have this letter v here, and here I have g, the second derivative of theta. Right, but we have here from equation 4 that the second derivative of g with respect to theta equals v. Okay, so I can go ahead and plug that in. And I get the second derivative of the log likelihood equals the negative alpha of phi times v. So all I've done is I've plugged in v for that function g. Okay, and that's what equation 5 says. So this is equation 5.